Chapter 3, Matter and Energy. So here's a picture of a room. Anything that we can see in this picture, the door, the windows, the ceiling, the floor, the rug, anything in there is matter. Anything you can see is made out of matter. And the differences between the properties of matter come from the differences in the molecules and the atoms that make them up. Now here they've given us a diagram of water. Here's a bottle. It's got water in it. So what's in the water? If we were able to, which we're not, if we were able to zoom in and see what was in the water, this is what we'd see. We'd see little water molecules. They remind me of Mickey Mouse heads. There's an oxygen and 2 hydrogen atoms, and each of them looks the same as the others. They're just kind of arranged randomly there. And here we have a golf club. Golf club, often made of graphite, and so this is probably an illustration of graphite. And we look at this illustration and it looks different, doesn't it? Here we have balls. They're all the same color and they're arranged very tightly. There's only one kind of atom in this graphite golf club. So what is matter? One definition of matter is it is anything that occupies space and has mass. So, what are some examples of matter that we can see? Anybody? How about the floor? Does the floor matter? The floor is matter. How about your pencil? That's matter. How about your chair? Does that matter? Yeah. Other kinds of matter we can't see easily with our eyes. There's a form of matter in here that we can't see, and yet it's really, really important in this room. The air, right? Air. Without the air, we'd all be dead, and that would be sad. We need air. We can't see it. Well, if you go outside and get a long vista these days, you can see the air. You're not supposed to be able to see the air. It's just really smoggy around here. But we can't see the air usually. But does it take up space? It does. You can put air into a balloon and it will fill up the balloon, right? Does it have mass? It does. That's not really obvious, but air does have mass. Matter generally appears to be smooth. I mean, we look at this desktop. It's pretty smooth. Does it look like it's made up of microscopic marbles? No. But when you get those little pieces small enough, then it starts to look smooth. Have any of you gone to Legoland in San Diego? Anybody? Oh, at least one guy, okay. They've got this area where they've got all these world monuments and things. They have the Taj Mahal made out of Legos, and they have Mount Rushmore made out of Legos, and it's like, I don't know, 10 feet tall or something, much smaller than the original. And Legos are little blocks, right? So we got these things made out of little cubes and squares and things. And if you look at them close, you see all the individual pieces. Just like a digital picture, when you zoom in, you see all the pixels, right? But when you zoom out, when all those little squares get small enough, it starts to look smooth. And so the particles in the matter that we can see are so small that it looks like it's just one continuous piece, when actually it's made up of a mind-boggling number of pieces. All matter is composed of atoms. So atoms are submicroscopic. That means they are smaller than what can be seen with a microscope. They're the fundamental building blocks of matter. So they are like, in a way, they're like Lego bricks. And you make everything else out of the Lego bricks. And what you end up with depends on what kind of bricks you use and how you put them together. So the atoms can bond together and form molecules. A molecule is just 2 or more atoms that are joined together. So if we're envisioning atoms as Lego blocks, then a molecule would be taking the blocks and putting them together and sticking them with super glue or something, so they're stuck together. Here's a picture of an aluminum can, and if we were able to zoom in and look at the aluminum atoms in the aluminum, it might look something like this. Individual aluminum atoms all lined up together. And here, this is an example where the atoms exist as independent particles. They're individual atoms in something like aluminum. Okay, let's see. Can anybody catch the mistake on this slide? What's wrong with this slide? Look at the labels. Here it says isopropyl alcohol, and here it says isopropyl alcohol, and what does it say on the bottle? Pure ethyl alcohol. Those aren't the same. Those are not the same. It just annoys the heck out of me. Anyway, I can't help seeing stuff like that. I'm sorry. So this is alcohol. When we zoom in, we see that the individual particles are not single atoms, but they're clusters of atoms. So the red ones are oxygens, and the white ones are hydrogens, and the black ones are carbons. And they're all clustered, they're stuck together. But each of these particles is like the other particles. So we've got molecules. So substances, matter can be composed of molecules or of atoms. This is a scanning, tunneling microscope image of atoms. So we're seeing them as these bumps that are almost like cone-shaped or something. That is not actually the shape of them. This is distorted because we just can't get a really good picture. What's cool about this, though, is that we can get any image of atoms. This one's cool. This is a scanning, tunneling microscope image of DNA. And if you look at this, we can actually see the double helix of the DNA. You see that in there? That is crazy cool. DNA is a very large molecule made up of lots and lots and lots of atoms. And yeah, that's not a great picture, is it? But it's a picture of a molecule. It's amazing.